Welcome to this video. So right now we're going to be reviewing for the midterm in order for you to be more prepared, at least kind of review some of the concepts that you may have done throughout the semester. There are about 30 multiple choice questions in the handout that I passed out to you, and then there is a fill-in chart portion. So let's go ahead and begin with number one. All right, so number one, we need to determine the x-intercepts for the quadratic function. Remember that to find the x-intercept, you have to set y equal to 0. So you're going to set this f of x right now equal to 0. So this is what we do here. So f of x is now equal to 0. And then now we're going to go ahead and proceed to solve. Since this is already factored, we can set each of these factors to 0. So now we're going to set them equal to 0 separately, as you see now. So 4x minus 5 is equal to 0, and x plus 8 is equal to 0. So then we're going to solve this this two-step equation and this one-step equation. So you're going to be adding 5 on both sides, on the left side, and therefore you get 4x equals 5. Then you're going to go ahead and divide by 4 on both sides, and for this side, for this equation, and then you're going to get 5 over 4. This one's already solved at x equals negative 8. So those are your two solutions. So x is equal to negative 8. And 5 over 4, which is 1.25. So the answer for this question is D. Looking at number 2, they want us to determine the vertex and the y-intercept for the quadratic. So in this case, you're going to need to know the vertex form, which is given below here. So f of x equals a times x minus h squared plus k. In this example, h is your HK are your coordinates for your vertex. So to find the vertex, you're going to be using HK. Once you identify the HK, then you're able to find the vertex. So in this example, 1 is equal to H and negative 2 is equal to K if you compare those two directly. Therefore, your vertex is 1 and negative 2. That takes care of the vertex. So now you need to find the y-intercept. So to find the y-intercept, you're going to set x to 0. So you're going to replace every single x in the function and replace it to 0. So this is what we're going to do. So now x is now 0, so we have 0 minus 1 on the inside of the parentheses. And 0 minus 1 is negative 1. Negative 1 squared is positive 1, and therefore we got a negative on the outside, so it makes a negative 1. Negative 1 minus 2 is negative 3. So the answer in this particular problem is C. The vertex is 1, negative 2, and the y-intercept is 0, negative 3. Now for this one, we need to determine the concavity and the vertex of the quadratic function. So recall that concavity, up or positive concavity, or or a positive leading coefficient, means that it's concave up. So remember that the leading coefficient is the number that is in front of the variable with highest power. In this case, the highest power is x squared, and so the leading coefficient is 3. If the leading coefficient is positive, that means concave up or a smiley face. So it's going to look like a U. If it's the leading coefficient is negative, then it's going to be concave down, and it's going to look like a frown. In this case, we have concave up since we have positive 3 as a leading coefficient. Now, next we're going to find the vertex of the quadratic function. So to find the vertex, you're going to need to pull out whatever or factor out whatever's in front of the x squared and the 12x, right? And you're going to set the 4 aside to the right. So you're basically going to ignore the negative 4, just kind of put them to the side. And then you're going to pull out the 3 from the x squared and the 3x squared and the 12x. If you pull out the 3, you're going to get x squared on the inside and 4x, because 3 times 4 is 12. All right, notice we have a little space here on the right side of this parentheses. And that's because we're going to be completing the square in this problem. So we're going to go ahead and complete the square. So in order to make this a perfect square, the trick is to take the middle number, which is 4, and dividing it by 2. And then squaring it. So 4 divided by 2 is 2, and then 2 squared is 4. So therefore, we're going to go ahead and add in the 4 inside the parentheses. So now we have it here inside. But however, notice that if I add a 4 there, I still have the 3 on the outside. So 3 times 4 is 12. And whatever I add to one side, I have to cancel it out by subtracting it on the other side, because everything has to balance. I can't just add a 4 there. I have to balance it out by adding a negative 4, or in this case, a 3 times 4, so a negative 3 times 4. Once I do that, well, we know that 3 times 4 is 12, and then we should x squared plus 4x plus 4. So this guy factors as x plus 2 squared, because 2 and 2 are the only numbers that work, that multiply to 4, but add up to 4. Once we do that, go ahead and combine your like terms. Negative 4 minus 12 is negative 16. And then now you notice that this follows the vertex form. So we can go ahead and identify the vertex, comparing it to this vertex form. Now, if we compare it directly, we can see that h is negative 2. It's not positive 2 because there's a negative sign here and a positive sign here. So therefore, it has to be negative 2. And here, the same thing. There's a positive sign on the vertex form, but a negative sign in the original. So k has to be negative 16. Therefore, our vertex is negative 2 and negative 16. And it's concave up. So in this case, the answer is A. For number 4, we're going to subtract these complex numbers together. Since you're subtracting them, what you want to do is change the subtraction sign in the middle to a plus sign, and then flip the signs on the right side as follows. So the minus sign becomes plus in the middle, and then you're going to flip the signs on the right side. So it used to be a negative 31, now it's going to be a positive 31. This used to be a positive 16, now it's going to be a negative 16. Now we can go ahead and simply combine like terms and add them. So we can combine the 56 with the negative 56 with the 31. We can combine the 45 with the 16, and therefore giving us negative 25 plus 29i. So the answer to this question is A. For number 5, you have to simplify the square root. So remember that if we have a negative inside the square root, that means that it's an imaginary number. So that means you're automatically going to put an I inside, in front of it, in front of the square root. So this is what we're going to be doing. So since there's a negative 72 on the inside, we're going to make it positive 72, but then include the I. So now it's imaginary. Now we have to break down the 72 into its factors so that we can simplify it further. So 72 is 9 times 8. And 8 is 4 times 2, so we have here 9 times 4 times 2. Notice that 9 is a perfect square and 4 is a perfect square. So what you can do is split the square root into each of those factors. So the square root of 9 is 3. The square root of 4 is 2. And then here you have square root of 2. So we're going to replace square root of 9 with 3, square root of 4 with 2, and then multiply the results on the outside here. So 3 times 2 is 6. 6 times negative I is negative 6i. And then just attach the square root 2 at the end. So this matches up with answer B. For number 6, now you're going to do a FOIL. So you're going to do first, outer, inner, last. So we do the first terms, which is 2 times 3. We do the middle terms, or the outside terms, which is 2 times negative 5i. We do the inside terms, 3 times I. And we do the last terms, I times negative 5i. Okay guys, so real quick, wanted to make a correction. So when we did the first, outer, inner, last, we got the first is 2 times 3. Outer is negative 2 times 5i. Inner is I times 3. And the outer is I times negative 5i. So I believe I had a negative sign here. It should have been positive. So we have I times negative 5i. In this case, we have 3 times 2 is 6, 2 times 5 is negative 2 times 5 is negative 10. Then we have 3i, and then we have negative 5i times I is negative 5i squared. Remember that I squared is equal to negative 1. So therefore, I'm going to replace I squared with negative 1 as follows. Then I'm going to go ahead and multiply. Negative 5 times negative 1 is 5, positive. Now I'm going to combine my like terms. So I know 6 plus 5 is 11. And then I'm going to combine the negative 10 and the 3 for I. So I get 11 minus 7i. So the answer is D. Now number 7, I want you to determine if the function is odd, even, or neither. So what are the requirements for being odd or even? Well, for even functions, remember that a function is even if when you plug in negative x into the function, you output the original function. So if I plug in negative x into this and I get the original function, then it's known as even. If I plug in negative x and I get like the function with all the signs flipped or reversed, then that's known as odd. So in this example, we're going to go ahead and replace x with negative x. So now I have, instead of x cubed, I have negative x cubed plus 5 times negative x plus 7. So negative x to the third power is negative because anything to the odd power, if it's negative, becomes negative, right? Because if you had negative 1 cubed, that would be negative 1 times negative 1 times negative 1. And 3 negatives, when you multiply, give you a negative. So therefore, we get negative. 5 times negative x is negative 5x. So it looks like this is the what we get. However, notice that neither of the signs are flipped, right? So like the negative x cubed has a opposite sign. So that one is flipped. The 5x is flipped, the sign is flipped, but the 7 is not. All right. In order to be odd, you have to have all the signs flipped. So therefore, this is not odd. And in addition, if you check the characteristic for even, you don't get the original function. So therefore, this cannot be even or odd. This has to be neither. So this is the answer to this is C. For number 8, you need to use concavity and vertex to determine how many intercepts this guy has. So what we're going to do, we're going to try graphing this guy. So remember that concave up, if you were to do concave up, so concave up means that the parabola looks like that, smiley face. Concave down means that the graph looks like this, all right, like a frown. So how do we know? Well, you look at that coefficient right there. That coefficient is a positive 2. The leading coefficient is positive. So therefore, it has to look like the smiley face, right, or concave up. So if we were to kind of graph this, right? So remember that the vertex form is ax minus h squared plus k. Therefore, if you look at this, h is negative 6, and k is negative 5. So that means the vertex is negative 6 and 5. Oops. There you go. So now we're going to go ahead and try to graph this. So negative 6 and 5. So 1, 2, 3, 6. And then 1, 2, 3, 4, 5. So this is our vertex, right? So now if you look at this, if you were to graph this, we know that it's a smiley face, so we know, or it's concave up, so we know it goes like that. So because it goes like that, that means we know it can't cross. Oops, I'm sorry. This is negative 5. I did this. I need to go down here. This is -5. I wrote -5 here, I didn't write here. So that's -5. 1, 2, 3, 4, 5. So that's -5. So -6 and -5. So we're all the way over here. All right, so that means it looks like it's concave up. So it looks like a smiley face. That tells me that it has to cross at these 2 points. It has to cross somewhere, and it has to cross the x-axis twice. So therefore, there are 2 x-intercepts here. So the answer is B. If it was how I drew it before, where it was all the way up here, let's pretend that it was all the way up here and we got a graph that looked like that. In that case, it would have no x-intercepts because it wouldn't cross the x-axis at all. Okay, so number 9, we're looking at using the discriminant. So let's go ahead and recall what the discriminant looks like. So this is the formula for the discriminant. So remember that the quadratic formula, where you solve for x if you're like trying to get the solution to a quadratic. Well, the discriminant is kind of like the same thing, except it's whatever is inside the square root. So in this case, this is the formula for the discriminant. So now identify your a, b, and c. You have to know how many solutions you have depending on your discriminant. So if the discriminant is positive, then you have 2 solutions. If your discriminant is 0, you only have 1 solution. And if it's less than 0 or negative, then you have 2 complex solutions. So identify your a, b, and c. So a is -5 because that's the first coefficient. The second coefficient is 6, so b is 6, and c is -2. Go ahead and plug those in into your discriminant. So we got 6 squared minus 4 times -5 times -2. Multiply, so -5 times -2 is 10. 10 times -4 is -40. And now we have 36 minus 40 is -4. Since the discriminant is negative, then that means you have complex solutions. So the answer is C. Okay, so for this problem, for number 10, you have to find the rate of change given the graph. So here we're looking at P of x. So P of x is given by the first graph here on the left. In order to calculate the rate of change, that's the same as calculating the slope, which is change in y over change in x. So in this case, our y is P. So we're going to use the graph to determine what our y values are. So if we plug, so what we're going to do is we're going to plug in 6 first and then -2 last into the function, okay? Because it wants from -2 to 6. So you're going to go final and then initial. So the final is 6, the initial is -2. So we're going to go ahead and plug in 6 and -2 into the function. So basically find out the y's from the graph. Then subtract the x's. The x is 6 and then the other x is -2. So if you look at the graph here, the x value or the y value at x equals 6 for the graph is 0 because it's right on the x-axis here. If you look at x is -2 and you look at the y value for the graph, the y value is 4 right here. That's at x equals -2. So therefore the p of 6 is, or p of -2 is 4 and p of 6 is 0. So we got 0 minus 4. Remember, if you have 2 negatives, that becomes a positive, so you have 6 plus 2. Now we go ahead and subtract, so 0 minus 4 is -4, 6 plus 2 is 8, and this reduces to -1/2. Therefore, the answer is C, -0.5. All right, we're going to be using the same graphs for 11 through 13. So really simple, all you have to do is you have to get f of -2. So that means you're going to use this graph here, the middle graph, to get the answer. So this is saying they want the y value when x is -2. So we're going to go to x equals -2, which is right here. And the y value is 2. So therefore f of -2 is 2. So the answer to that is B for number 11. For number 12, we're going to be using the same graph, where now we're going to go to x is equal to 2 right here. And then the y value is, oh, look at that. So there are 2 points here, but they're not filled in. That's telling me that there are no points for x equals 2, which means that there is no y. So that means it's undefined. So the answer to number 12 is undefined, since there are no filled in points there. See that those points are not filled in at all. Now we're going to use h, so we're going to use the right side. So in order to do this, we're going to plug in -6 into the function. We can only plug it in for x here. So we're going to go ahead and show you how to do this. Let's go ahead and show you here. So we have x squared plus 2x minus 3. And we're plugging it in, we're going to plug it in -6. So we have -6 squared plus 2 times -3, or -6, sorry, minus 3. So now we got -6 squared is 36. So we got 36. And 2 times -16 is -12. Then we have minus 3. Now we're going to go ahead, 36 minus 12 is 24. 24 minus 3 is 21. Okay, so your answer for number 13 is 21. Remember, we plug in the -6 because here x is less than or greater than or equal to. So you see that equal sign underneath? That means that you're going to use this function for -6. You can't do it for the top one because it doesn't have an equal bar. It says it's strictly less than, not less than or equal to. Number 14, they give you a function, and that function gives you the height of a baseball as a function of time. They want you to use a quadratic formula to determine how long it takes for it to hit the ground. Remember, when it hits the ground, that means that the height is 0. So h is 0. So therefore, I'm going to set h equal to 0 first on the left side. Now I have to figure out what my a, b, and c are and plug it into the quadratic formula. So my a is -16, my b is 30, and my c is 4. So I'm going to plug that into the quadratic formula. So I'm going to plug in 30 in for b, -16 for a, and 4 for c. So now I just got to do the math here. So on the inside, I have 30 squared is 900, because 30 times 30. 4 times 16 times 4 gives me 256. I add whatever's inside the square root, which is 1156. The square root of 1156 is 34. Now it wants you to add and subtract, so I'm going to be subtracting first. So -30 minus 34 is -64. I go ahead and divide those and I get 2. On the right side, I'm adding them. So -30 plus 34 is 4, and then I get a fraction, 4 divided by -32, which is -0.125. Note that I'm going to ignore the negative time because it doesn't make sense for the ball to hit the ground at -0.25 seconds. So therefore, I'm going to go ahead and ignore that answer, and I'm going to say that the time it hits the ground is 2 seconds, since that's positive. So the answer to this is D. Alright, so number 15 is just a review of factoring. So remember, in order to do this, you need to set up your x table. So you have 36 on the top, -12 on the bottom. The only two numbers that work for this problem is -6 and -6. Therefore, we can go ahead and factor this. So we have k minus 6 times k minus 6. That's the same thing as k minus 6 squared. So the answer is part C. Number 16 wants you to factor as well. However, you'll need to remember how to factor cubes. So for this guy, you're going to need the sum of cubes formula. So the sum of cubes formula is given by the following. equation. So this is the formula for sum of cubes. So what we need to do is identify what a is and b is. So we know that a cubed is z cubed if you were to match those together. And we can see that b cubed has to be 64. So then if a cubed is z cubed, that means that a is z in the formula. And if b cubed is 64, well, to get that, we need to take the cube root of 64. So that's going to be 4, since 4 times 4 times 4 is 64. Now that we know what those are, we can go ahead and plug those in. So a is now z, b is 4, so we got z plus 4. A squared is now z squared, and then we have a times b is 4 times z, and we have b squared is 4 squared. So that means 4 squared is 16, and that is our final answer. So you just got to know the formula in order to plug it in. Number 17 wants us to factor as well, but remember that this is a difference of squares. So the difference of squares is a squared minus b squared equals a plus b, a minus b. So we got to identify our a and our b. So in this case, a squared is equal to n to the 4th. If you were to match those, they match out perfectly. A squared is n to the 4th, and b squared is 16. So in order to find b, you're going to take the square root of 16. 4 times 4 is 16, so that means b has to be 4. A squared is n to the 4th. So when you take the square root of n to the 4th, you're going to get n squared, because n squared times n squared is n to the 4th. So you're going to plug this in directly into the parentheses. So n squared is a, b is 4. So we have n squared plus 4 and n squared minus 4. However, we're not done yet here, because the answer here looks like a, but it's actually not a, because it wants us to factor completely. Remember that n squared minus 4 is also a difference of squares. So since that's a difference of squares, we need to go ahead and use the same formula. In this case, a squared is n squared, and b squared is 4. So a has to equal n, and b has to equal 2. So therefore, this is actually written twice, so you don't need both of those. But then since we know what a squared and b squared are, we can go ahead and plug it in. So we got n squared so n squared minus 4 becomes n plus 2 and n minus 2. So therefore, our completely factored form is n squared plus 4, n plus 2, and n minus 2. All right, so now for number 18, we want us to factor again completely. So again, we're trying to review the factoring stuff. So this is a factoring by grouping problem. So you're going to group or put parentheses around the first half and second half. Then you're going to pull out from each group. So from the first group, you can pull out a y squared. From the second group, you can pull out a negative 9. When we pull out a y squared, it gives us y plus 1. And then when we pull out a negative 9, we get y plus 1 on the inside. So since these two match, that means you're doing this correctly. Now we're going to go ahead and, now that we have y plus 1 as you see that you have two of them, go ahead and make one of them your factor. So y plus 1 is one of your factors, and your other factor is y squared minus 9. Remember that y squared minus 9 is a difference of squares, so that means that you can replace it as y plus 3 and y minus 3. Remember that 3 times negative 3 is negative 9, and then 3 plus negative 3 is 0. So therefore, this works. You can go ahead and replace this, y plus 1 times y plus 3 times y minus 3. And that's your final answer. For number 19, we're going to go ahead and determine the end behavior. In order to determine the end behavior of this, you're going to need to do some graphing, or at least get an idea of how this looks like. So what we're going to do is we're going to go ahead and graph this. Just do a basic graph. So this is the function, so now we're going to go ahead and graph it. Remember that here, this is an odd function, because this has an odd degree. Okay, so what you look at is you look at the highest power. So the highest power is 5. So that means that the degree is equal to 5. Now, because the degree is odd, so this is odd, and the leading coefficient is negative, that means that this graph behaves, has the behavior where it starts out positive and it ends up negative on the right side. So you have to know the end behaviors, okay? So like, for example, if you had even and odd, so we're going to go ahead and do even or even positive. So if you had a graph that's even and positive, then it's going to look like a smiley face parabola, right? So it's going to start out on the left side, it's going to go up, on the right side, it's going to go up. If you have a graph that is even and negative, so even degree and negative, then it's going to, on the left side, it's going to be going down, on the right side, it's going to be going down. If you have a graph that is odd and positive, that means on the left side, it's going to start out going down, and on the right side, it's going to go up. And then if it's odd negative, which is what we have here, it's going to go up on the left side and go down on the right side. So in this case, since we know it behaves like this will help us with our end behavior. So it doesn't matter exactly how the graph looks like. We just want to know how it ends up. It can look like this for all we know, as long as we know that on the left side it goes up, on the right side it goes down. So now because we know that, now we can do the end behavior. So as x gets more and more negative, because this is negative infinity, the graph is actually trying to go up. So therefore it's trying to approach positive infinity. So that means as x approaches negative infinity, y approaches positive infinity. As the graph goes to the right, or when x goes to positive infinity, the graph is going down or negative infinity. So therefore, as x approaches positive and positive, we're going to go down. As x goes more negative, we're going to go up. So that is answer choice C. So for number 20, we're going to go ahead and use long division to do this, since that's what directions specify. So we're going to put 2x minus 3 on the outside and 6x squared plus 5x plus 21 on the inside. So 2x times 3x gives us 6x squared. So therefore, this top part has to be 3x. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. You're going to go ahead and subtract those. So the 6x squareds cancel. 5 minus negative 9 is 14x. Bring down to 21. 7 times 2x is 14x, so therefore this has to be a 7. 7 times negative 3 is negative 21. Go ahead and subtract those. So the 14x cancels. 21 minus negative 21 is 42. Now that we got the main part of the division, remember that if we have a remainder, we have to take that remainder and put it over the divisor, or original denominator. So therefore, we're going to put the 42 over the 2x minus 3. So our final answer is 3x plus 7 plus 42 over 2x minus 3. And that is answer choice A. All right, number 21, we're going to determine the remainder of this guy if we divide by x minus 4. So we can either use long division or synthetic, sorry. So therefore, we're going to use synthetic here just to make it easier. Since we are using synthetic, the outside number is going to be 4 because we have x minus 4. It flips signs. So the outside number is 4. On the inside, we have 2, negative 13, 9, and 0. Bring the 2 down. 4 times 2 is 8. Go ahead and add that up. Negative 13 plus 8 is negative 5. 4 times negative 5 is negative 20. 9 plus negative 20 is negative 11. 4 times negative 11 is negative 44. 0 plus negative 44 is negative 44. Therefore, our remainder is negative 44, or B. This is the unit that you were working on Algebra Nation. So now, in order to do this, we need to use the following formula for the arithmetic sequence. In this case, A1 is the first term in the sequence. D is the difference between any two terms in the sequence, or how far you had to travel to get to the next number. And N is the number of terms, or the term number that you're looking for. In this case, we're looking for the 38th term. So in this case, N is 38. In this example, remember that D is the difference between any two numbers that are next to each other. So we can pick any two numbers that we want as long as they're next to each other. So I'm going to take the difference between the first two terms. So final minus initial. So negative 10 minus negative 11.2. If I subtract those, I get 1.2. So now we said N is 38 because we're looking for the 38th term, A38. A1 is the first term. And D is the common difference that we found earlier. We can go ahead and plug those into the formula and do the math. And that gives us that A38 is 33.2. For number 23, we're going to be doing the sum of the geometric series. So the sum formula is as follows. So we had to take the first term, which is A1, and then we're going to multiply it against 1 minus r to the n over 1 minus r. So r is known as the common ratio, and to find r, what you need to do is you need to take you can take any two terms from the sequence and basically divide them. So remember that arithmetic sequence is when you add or subtract to get to the next number. Geometric series is when you multiply or divide to get to the next number. In this case, if you take negative 12 divided by 4, the first two terms, and divide them, you're going to get negative 3. And that tells you that to get to the next number, you have to keep multiplying by negative 3. So that's what R stands for. So now that we know what R is, we know that N is 8 because they said that the series has 8 terms. And we also know that the first term is 4. So we can go ahead and start plugging in and do the math. So we got negative 3 to the 8th power is 6,561. This was done on the calculator. 1 minus that 6,561 is negative 6,560. I'm going to go ahead and divide those. So negative 6,560 divided by 4 is negative 1,640. Multiply those and I get my final answer. All right, so now number 24, we're looking at domain. This is kind of the stuff that we've been doing. So we did factoring, but we also did rational functions, that's what this covers. So remember that the domain is a set of all x values. And to find a domain for a rational function or a function that's a fraction, what we need to do is we need to set the denominator to 0, because that denominator is going to tell us where, like, that denominator cannot be 0. So if we figure out where the denominator is 0, we can figure out what x cannot equal to. So we're going to go ahead and set the denominator to 0. And we need to factor that guy. So we need the factors of 8 that add up to negative 9. So that's the only numbers that work is negative 8 and negative 1. So therefore, this is how we factor it. Then we set both of those factors equal to 0. And we get that x cannot equal to 8 because if it equaled 8, we're going to get 0. And x cannot equal to 1 because if we plugged in 1 there, we also get 0. So therefore, the answer to this question is C, all reals except for 1 and 8. All right, number 25, we want to, hold on here. All right, sorry about that. So number 25 wasn't posted at all. So now it's posted. So now, in order to find the x-intercept, we need to set y to 0. So therefore, we're going to set y to 0. In this case, y, we're looking at g of x. So we're focused on the middle function here. So we're going to plug in 0 in for g. All right, g is the same thing as y in this case. So we have 0 equals that. In order to solve for x, we need to multiply both sides by that denominator because we want to get rid of that denominator. So we're multiplying both sides by that denominator. But 0 times anything is going to be 0. And then on the right side, the denominators cancel. The denominator cancels with that number that we multiplied. So therefore, that leaves us with 0 on the left side and x squared minus 4 on the right side. Now we can solve for x. So we're going to add the 4 to both sides, so we get x squared equals 4. Now we can take the square root. Remember that if you take the square root, you have two solutions. You have positive 2 and you have negative 2. That's because 2 times 2 is 4, but negative 2 times negative 2 is also 4. Therefore, you have two solutions. So the answer to this question is C, negative 2, 0, and 2, 0. For number 26, we need to determine the y-intercept for h of x. So we're looking at the right function, the right side here. We're looking at this guy. So we need to set x to 0. To find the y-intercept, we set x to 0. So therefore, we replace everything that you see on the right side of h of x to 0 for x. So now 0 squared minus 25 is negative 25. 0 squared is 0. 3 times 0 is 0. So it leaves us with negative 10 on the bottom. Negative 25 divided by negative 10 is 2.5. So the answer is D. Number 27. Determine the vertical asymptotes, if any, of f of x. Remember that to find the vertical asymptote, you need to set the denominator to 0. However, you also have to be careful to make sure that the denominator doesn't cancel out with anything in the numerator. So what we're going to do is we're going to first factor the numerator and denominator separately to see if anything cancels. This is one of those tricky questions. So if you look at the numerator, we can't really factor that. So it leaves us with x minus 1. However, the denominator we can factor. We need the factors of two numbers that multiply to 8 but add up to negative 9. The only numbers that work are negative 1 and negative 8. However, notice that the x minus 1's cancel. Because they cancel, it leaves us with 1 over x minus 8. So we only have an x minus 8 left over. So since the x minus 1's canceled, that means that that is not part of the vertical asymptote. The only thing that's part of the vertical asymptote is x minus 8. Now we can go ahead and set that denominator to 0. When we set that denominator to 0, we get x minus 8 equals 0. So the only thing that works for that is if x was 8, because 8 minus 8 is 0. And so that's our answer. Our answer is B. For number 28, we need to solve this proportion. So this is going back to chapter 8. One of the last sections, chapter 8, lesson 3, when we were solving. So what we need to do is we need to cross multiply. So we're going to do n minus 6 times n plus 2 equals n plus 4 times n minus 1. So we're going to need to FOIL this. So when we FOIL the left side, we get m squared. And then we got m times 2 is 2m. Negative 6 times m is negative 6m. Negative 6 times 2 is negative 12. When we FOIL the right side, we get m squared. We get m times negative 1 is negative m. 4 times m is 4m. 4 times negative 4 is negative 4. Now we're going to go ahead and solve. Remember, this is quadratic, so you want to make one side equal to 0, so you want to move everything else to one side. So I'm going to go ahead and, before I do that, I'm going to combine like terms to make it easier for me. So I know that 2m minus 6m is negative 4m. I know that negative m plus 4m is negative 3m. Now we can start moving things over. So I'm going to subtract the m squared on both sides. So if I subtract the m squared on both sides, they cancel. leaves us with negative 4m minus 12 on the left, negative 3m minus 4 on the right. Now I can go ahead and add 12 to both sides, because what I want to do is I want to move the variables to the left and I want to move the numbers to the right. So I'm going to get rid of the negative 12 on the left. I'm going to add it over. Negative 4 plus 12 is 8. Now I'm going to move the m over to the left side. So I'm going to get rid of that negative 3m. I'm going to add 3m to both sides, and I get negative m is 8. I'm almost done here. If negative m is equal to 8, that means m is negative 8. All right, now remember, we got to plug this in to the denominators to see if they get 0. So in this case, negative 8 plus 4 is not going to give me 0, and negative 8 plus 2 is not going to give me 0. Therefore, this is my solution. The answer is A. Number 29. So what we're going to need to do is we're going to need to find the least common denominator. In order to do that, we need to factor the denominators. So we're going to go ahead and factor the first part. Notice that I can pull a v out of the first denominator. If I pull out a v, I get a v times v minus 4. I can't factor anything else, so I'm done here. Now I'm going to find the least common denominator. Least common denominator is v times v minus 4, because they all have a v and they all have a v minus 4. So I put them together and I get v times v minus 4. Now I must multiply everything by the LCD in order to get rid of those denominators. So I'm multiplying everything here. Notice that the first fraction, the denominator cancels out completely. On the second fraction, the v's cancel out. On the third fraction, the v minus 4 cancels out. Therefore, on the first fraction, since everything canceled out, we have 8. On the second fraction, the v's canceled out, so we got v minus 4 and v plus 2. On the right side, the v minus 4 canceled, so we got 7 times v. Now we're going to need to FOIL the v minus 4 and v plus 2. V times v is v squared. V times 2 is 2v. Negative 4 times v is negative 4v. And negative 4 times 2 is negative 8. Now we're going to go ahead and combine like terms. 8 minus 8 is 0. 2v minus 4v is negative 2v. Now we're going to go ahead and solve. So since this is quadratic, we need to move the 7v over to the left side. Move everything to one side. So I'm going to subtract it on both sides. Negative 2v minus 7v is negative 9v. We can factor this by pulling out a v. So we're going to go ahead and factor that out. When we pull that out, we get v times v minus 9. Now we can set both of these things to 0. So now we know that v is equal to 0 and v minus 9 is equal to 0. So therefore, v is equal to 9. Remember to check for extraneous solutions. So in this case, v cannot equal to 0 because if we plug it into the second fraction, you get 0. Therefore, v equals 0 is extraneous. So that is not a solution. However, if you put in 9 into it, you're not going to get 0. 9 minus 4 is 5. 9 squared minus 4 times 9 is not 0. So we're good there. And if you plug in 9 into the second fraction, you don't get 0. Therefore, the only solution is 9. So the answer here is A. All right, looking at number 30. So for number 30, we need to match the graph with the equation. So we're going to go ahead and look at that. We're going to need to look at the horizontal asymptote. So notice that the horizontal asymptote is at negative 5. That tells me that the function is shifted down by negative 5. Therefore, I know that I'm going to be subtracting 5 to the function. The only one that has minus 5 on the outside is C. This negative 5, remember that negative 5 means it shifts it to the right 5, not down 5. C tells us it shifts it down 5. So therefore here the answer is C. It's not shifted to the right or left at all, so therefore I know there's nothing on the bottom with the x. So therefore it has to be C. Now let's look at the table, filling in this table. So we know that the coordinates for f are negative 4 and 0. That means the x coordinate is negative 4. and the y-coordinate is 0 for f. So what we do is we set x plus 2, which is here, and we set it equal to -4. Because we know that since x is -4, we know that whatever's inside the x plus 2 has to be -4. So we get x plus 2 equals -4, which means you subtract 2 on both sides, so x is equal to -6. Okay, so that's going to be for the x transformation. For y, what we do is we know that y is 0 here, so we're going to go ahead and plug in 0 in for y, which is the same thing as f. So now we got f is 0, so 3 times 0 minus 6 is -6. For the next part, for the second part, we're going to go ahead and set x plus 2 equal to 5, because that's what x is equal to, and this whole thing has to equal to 5. So therefore x plus 2 equals 5, so that means x has to be 3. If you plug it in, you get 3 plus 2, which is 5, which makes sense because this has to be 5. Now we know that the y is -6, so we can plug in -6 for f. So we got 3 times -6 minus 6 is -24. Looking at the last one, we're going to set x plus 2 equal to 7. So if x plus 2 equals 7, x has to be 5. We also know that the y is 2, so we can plug that 2 in for f. So we got 3 times 2 minus 6 is 0. Alright guys, and that's it. So I hope you found this useful, and happy studying.